Every day, we place our hands on a machine that turns thoughts into action. A machine that writes our stories, builds our ideas, and connects us to the world. It sits quietly on our desk, always ready, always waiting. The keyboard is one of the most used devices in modern life, but most of us never think about how it works. We press a key, and something appears on the screen. Simple on the outside, complex on the inside. Today, we're going beneath the surface. We're exploring the hidden world under your fingertips. This is the journey of a single key press. Let's start with the moment you press a key. Your finger applies a small amount of force. The keycap moves down. A spring compresses. A switch begins to travel. Then it reaches a special point, the actuation point. The moment the keyboard decides, yes, this is a real key press. A tiny electrical connection is made. A circuit closes. A signal wakes up. Think of it like a messenger running through a tunnel of light. Your intention becomes a signal. A physical action becomes a digital event. The first layer is the keycap. It's the part your fingers touch every day. Keycaps come in different shapes and materials. ABS plastic is smooth and light. PBT plastic is textured and durable. Some keycaps are sculpted. Some are flat. Some are designed for comfort. Others for speed. The keycap is the personality of the key. Under the keycap is the switch. This is the heart of the keyboard's feel. Linear switches move smoothly. No bump. No click. Tactile switches give a small bump. A moment of feedback. Clicky switches snap loudly. They create a sharp, crisp sound. Inside each switch is a stem, a spring, and a mechanism, all designed to capture the exact moment you press the key. Large keys need help to stay balanced. Keys like the spacebar, enter, and shift. Stabilizers keep these keys steady. When they're tuned well, they feel smooth. When they're tuned poorly, they rattle. Stabilizers are small parts, but they make a big difference. Below everything is the PCB, the printed circuit board. It holds every switch. It carries every signal. It's the nervous system of the keyboard. Some PCBs allow hot swap sockets. You can change switches without soldering. Others are soldered permanently for strength. But all PCBs share one purpose: to move the signal from the switch to the keyboard's brain. A keyboard doesn't have a wire for every key. That would be messy and expensive. Instead, it uses a matrix, a grid of rows and columns. Imagine a city at night, streets running one way, avenues running the other, intersections glowing with light. Each key sits at one intersection. Press it, and you connect a row to a column. The microcontroller scans this grid many times per second. It looks for intersections that light up. That's how it knows which key you pressed. But the matrix has challenges. Cheap keyboards can get confused. Signals can overlap. Ghost keys can appear. Some keys may not register. Better keyboards use advanced scanning. They support multiple key presses at once. This is called rollover, 6-key rollover, or full N-key rollover. At the center of the keyboard is a tiny computer, the microcontroller. It reads the matrix. It interprets the signals. It decides which key was pressed. Then it sends that information to your computer. It uses USB or Bluetooth. USB sends small packets of data. Bluetooth sends radio signals through the air. Every letter you type starts as a tiny electrical pulse. The microcontroller turns that pulse into a message. Here's something most people don't know. Your keyboard does not send letters. It sends numbers. These numbers are called key codes. When you press the A key, the keyboard does not send the letter A. It sends a key code. Your operating system receives the key code. Then it decides what character to show. That's why the same keyboard can type many languages: English, Arabic, Swedish, Japanese. The keyboard sends a signal. The computer chooses the meaning. A key press becomes a key code. A key code becomes a character. A character becomes a sentence. Not all keyboards work the same way. Membrane keyboards use rubber layers. They are quiet and inexpensive, but they feel soft and less precise. Mechanical keyboards use individual switches. Each key has its own tiny machine. They are durable, customizable, and expressive. Typing on a membrane keyboard feels like pressing into a cushion. Typing on a mechanical keyboard feels like playing an instrument. For many people, keyboards are more than tools. They are hobbies. They are art. Switches can be lubricated. Stabilizers can be tuned. Foam can be added to shape the sound. Cases can be customized. Keycaps can be collected. Some people chase the perfect sound. Some chase the perfect feel. Some chase the perfect look. A custom keyboard becomes personal, a reflection of the person who built it. So the next time you type a message, write a line of code, or search for an idea, remember the world beneath your fingertips. The switches, the circuits, the matrix, the microcontroller. A tiny universe working together to bring your thoughts to life. This is the machine beneath your hands. And now, you know its story. Thanks for watching, and I'll see you in the next chapter of this digital adventure.